Good morning, Geo students, and welcome to your second set of notes on population. It's going to be part one of two sets of notes on population. In this set, we're going to answer the question, where is the world's population distributed, and how do we measure population? So why do we study population, first of all? Well, probably good to know that demography is the technical name for the study of population. One thing that we need to note that's significant is that our current population is at 7.8 billion people, which means it's approaching 8 billion. Over the last 100 years, we've been on a record pace for our population increase. And one of the other trends we've noticed is that the rapid growth occurs in many of the less developed countries, and that's a pattern that we can trace back centuries. Other issues that face us as our population continues to grow on the planet: overcrowding, sanitation, pollution, and of course, shortage of resources, food in particular. Looking at this chart, you'll find that the population growth through the 1700s to about the mid-1900s was starting to increase. It had been pretty steady prior to that and shot up quite significantly then from 1960 through today, where we are now at 7.8 billion. The projections are that it may round off once we hit the 11 billion range, but that's going to be 80 years down the road. We don't know if that's the case or not, but that's what we think might happen moving forward. So when we talk about less developed countries where the majority of the population growth is, it's probably good that we define what an LDC is versus an MDC, because these terms will be used again when we look at industry and development of countries as well. So more of our LDCs are located in areas south of the equator. So we're talking sub-Saharan Africa, we're talking most of Latin America, some of Asia, especially as you start getting inland, Eastern Europe, which is emerging out of that LDC stage into the NIC stage. And then when you talk about more developed countries, you have North American nations, Western Europe, Japan, Australia, New Zealand. Now, down at the bottom of the slide, we've noted that in between the LDCs and the MDCs, you have NICs. So you have what could be considered the richest of the developing countries or the poorest of the developed countries. So you have countries like Brazil, Russia, India, and China are emerging and marching their way towards becoming MDCs. Same can be said for Mexico, Indonesia, South Korea, and Turkey. The map of the world that you're looking at here is a cartogram showing countries, populations. So the size of the country is going to indicate which are our most populous countries in the world. This should correspond with the Least You Should Know map that you just finished for this class last week. The four major population clusters that you find in the world, three of the four are found in Asia. You have East Asia, which is marked with China having a large population, well over 1 billion. South Asia, marked by India having also a population of well over 1 billion. Southeast Asia, where you have many countries with large cities developed along the coastlines because they are tremendous shipping ports. And then lastly, Europe, where you have a smaller continent in terms of land size, but lots and lots of cities that have developed over the last 1,000 years there. When you look domestically at the United States, a major cluster that can be found is on the East Coast, going from Boston, running all the way down to Washington, D.C. Think of cities like along the way like Hartford, New York, Philadelphia, Baltimore. It's almost like you're in one continuous city. And when you look at this map, if you want to look for trends about the population clusters, what do they have in common? Well, one, they're fairly close to the coastlines. Two, if you zoomed in on the map and this map actually had the physical features, you find they're located along rivers or water sources, which means that these areas are also good for agricultural production. So people are close to water and food, and of course those things are essential. Also, the climates are more conducive for living, right? The further you get away from the equator to the north or the south, the colder the climate becomes. And so you're not going to find as many people able to survive there. And also when you're just a little bit away from the equator, you're talking about really dry desert-like regions, and those are also difficult to inhabit. A review for you. The world's approximate population is 7.8 billion. The majority of the world's population lives on which continent? Well, 3 of the 4 major population clusters were in Asia. When we look at sparsely populated regions, a term we want to be familiar with is ecumeny. Ecumeny is what we call the areas of the earth where humans do live. And we have to understand when we look at our globe, most of the world's population lives on a very small amount of land. In fact, the statistic we give you is 3/4 of the world's population lives on 5% of the land, which means there's lots of sparsely populated places that have dry land. So think of deserts, or wetlands where it's so swampy or boggy that it's difficult to farm, it's difficult to build permanent homes, and also there's probably large amounts of insect infestation, which leads to disease and, again, difficult environments to survive in. Lands that are cold, again, further away from the equator, it's going to be sparsely populated. And as you get up in the mountains, again, difficult to grow things in rocks, and also colder climates. Next, when we start measuring population, we want to consider the density of something. The idea of density is how many things are there in one given space. So there's 3 different types of density we need to be aware of. One is arithmetic density, and so this is a very basic measure of population where you're just taking the land area of the country and dividing the number of people that are in it by the land area. So you find out how many people are there per square mile. So for example, if we look at just arithmetic density around the world, Monaco is the most densely populated country in the world at 33,000 people per square mile. So it's about a little less than the total population of Cottage Grove, all contained in 1 square mile. Mongolia is the world's most sparsely populated country in terms of arithmetic density, 5 people per square mile. However, arithmetic density can be misleading. And so physiological density is probably a better measure, where we're looking at the number of people in the country, and then we divide it by the arable or livable land area. And so that creates a much different story. You'll see that as we move forward in some slides here. And then the last population density measure that we like to use too also helps us understand how developed or how technologically advanced a country might be becoming. And that's where you take the number of farmers in a country and divide it by the amount of land area that is farmable. Now, when you have countries that have a large number of farmers divided by the farmable land area, you're looking at a less developed country. In more developed countries, you have less farmers because one farmer can produce food on a much larger tract of land if you have technology like combines and tractors and things of that nature. So when you look at this map, here's a map of the world showing the arithmetic density. And what I want you to focus on as I move forward here is look at Africa and South America. So arithmetic density, people per square kilometer. Now, when I go to physiological density, look what happened in the Southern Hemisphere. Now we've got a much denser set of population. See that? I'm going to go back. Now I'll go forward. And that has a lot to do with the fact that at this time, a lot of that land in that part of the world is hard to inhabit. That's why we look at physiological density as being probably a better indicator of how packed in or overpopulated or crowded a country could be. And lastly, here's it showing the agricultural density. So these are countries in the world where farmers have to work a lot harder, either because it's a tough climate to grow crops in or due to lack of technology. So if we think of global population clusters and where they're mostly located, is it by rivers or coasts or fertile land, or do all 3 of those things seem pretty reasonable? I think you can conclude that they are all reasonable, therefore all the above. The number of farmers per square mile of farmland, well, if it has to do with farming, that makes it agricultural. So let's go agricultural density. Now, last piece, when we start measuring population, there's 3 that we're going to need you to use as you do an assignment building off of these notes when we're measuring how fast population is growing. One measure is the crude birth rate, also known as the CBR. You see the world average right now for crude birth rate is 20 people, and that is a measure of the yearly Number of births out of every 1,000 people. So out of every 1,000 people in a country, how many were born in the past year? Another statistic you need to be familiar with is the crude death rate. You can see the world's average is 8, and that's a measure of the number of yearly deaths for every 1,000 people. So out of those same 1,000 people, where we had 20 of them were born in the last year, how many died in the past year? Now notice, if you have 20 people that are being born and only 8 that are dying out of every 1,000, that means you have 12 more people that you're adding, right? Or 1.2% more. When you look at the third statistic, the natural increase rate, that is a measure where you're looking at the crude birth rate of a country minus the crude death rate. If a country has a positive number, then you're looking at population growth. Worldwide, the statistic we want to give you is that population growth is at 1.2%, or approximately 80 million more people per year. Over the last 12 years, we've added nearly 1 billion people to the planet. At our current rates, our doubling time, or the amount of time it takes for the population of the Earth to double, is 54 years, or half a century. 95% of the growth that we're looking at, and you'll see this in your assignment when we start identifying countries with really high birth rates and low death rates, are going to be located in LDCs. Here's a reference map for you to look at the natural increase rate. And so where we're seeing the largest increases are in those countries that are right around the equator: Africa, Southwest Asia, South America, Central America. You look at crude birth rate, again, largest numbers of birth rate in sub-Saharan Africa. Other measures that are worth noting: so the total fertility rate. So this is the average number of children that a woman's going to have in her lifetime. When you look at a country and its level of development, in general, when a country has a lower number for a total fertility rate, meaning women are having less children, you're likely looking at a country that is more developed, because there's a pretty good chance that women in that country are also choosing careers, and so they're choosing to have less children or less large families. Another one is the infant mortality rate, the IMR. The world average, you can see, is 46. That's the number of babies that die before the age of 1 out of every 1,000 births. Ideally, a country would like to have a lower number for infant mortality rate. Life expectancy is another measure, and you're looking at the average age that a person lives to in a country. So the world average is at 68.9 years old. More developed countries tend to have numbers that are higher than that. Least developed countries are going to have numbers that are lower than that. So these are reference maps for your crude birth rate, your crude death rate. Here's total fertility. So again, these countries are where you're looking at larger families. Women are having, on average, 4 or more children in the countries that are dark green. Infant mortality rate is also detectable in countries that are less developed. And you can see the higher the infant mortality rate, the less developed the country is. And that also helps explain why women are having more children in those countries, because if the children are likely to die at a younger age, they need to restore that population within their household, and so they might have more kids as a result. There are also other factors involved that we'll get to later on in this unit. And then this is showing us our life expectancy around the world. So the countries that are the dark green are going to be the countries that have the highest levels of development. Note the United States is not quite in the top tier, but if I remember right, we're somewhere in the upper 70s for our life expectancy. So, important question for you here. When you take the crude birth rate, you subtract the crude death rate from it, the number that you end up with is called the NIR, or when you shuffle up those letters, the rate of natural increase. Question number 6, the average number of children a woman will have in her lifetime is called the fertility rate. Question number 7, most of the world's population growth is occurring in the least developed regions of the world. That is a true statement. Thank you for tuning in, and we'll start digging more into population and getting into an activity where you're looking at actual data for countries around the world.